This time we're going to calibrate or look at the line sensor and how to calibrate that. And so I'll start by moving the robot, if I am allowed to do that. Oops. So that the sensor fully sees the white line. I need to turn it on again. And I'll put it something like this. It's fairly easy to see that all the LEDs are illuminating the white part of the tape. And now the values are around 3000, but if I press reflection on white, it will move the actual values to this column, the calibration value. And when I say apply, it will use that. And to see if it then thinks that this is the same white color, I can show normalized, and we can see it's totally horizontal. And that's the correction that the software will do to get some good values to work on. It also says black. And if I move forward a little bit, I will get some other values. If I move around, then you can see over here on the values that there's a lot of difference. So we shouldn't use the floor as black. So what do we use? Well, we'll just make it look at nothing. So I will do that. I'll just tip it. Well, it can still see a little bit, but it's close to nothing. And I will say, well, this is my reference. This is an okay reference. And I'll move it back. And this is the calibration of black and white. And we will then try to move it. So I'll move it the other way around, so we have a chance to see what goes on. So now it looks like half of the line sensor is on the line and half of it is not. But the sensors are wider than the LEDs, so it's not just taking the LEDs, it's taking a wider area. And we can see that this part of the sensors, the last 3, 6, 7 and 8, I can show it normalized. So the last 2, 7 and 8, they are more equal, and then it goes down because the sensor sees a wide area, which sort of averages it out a bit. And we can see the left edge and the right edge after the calculation. It says the left edge is 0.6 and the right edge, that's over here. And the edge, it can't even see the edge. So it says that the edge is 3 centimeters or 3 values. It as approximately centimeters, but we'll see it as values. And 0 is in the middle. And 3 plus minus 3, that's the extremes. So if we move it a little bit away. So now this left edge is close to 0. That means in the middle of the sensor, which seems right. Now this edge is about in the middle of the sensor. And there's a value up here saying line valid equal to 20. And the validity of lining and crossings, that we'll get to in a moment, is between 0, which means no line or no crossing detected, and 20 means that it has seen the line, that line has been valid for at least 20 measurements, and that means 20 milliseconds. And if I go forward with the robot, we can see that the values move. It makes it more negative. The left edge is over here. And we are getting closer to that edge, further away from the middle. And if I go even further, then it increases to 3, and the other one decreases. Now we can see the right edge of the robot. And if I go further, it'll go further away. And now we get too far away, and the line valid is no longer valid. We can't see a line. If I go a little bit back, the line validity will increase again. So this is how the line sensor works. There is an oddity on Windows, and that is that these values can freeze. And a trick to make them unfreeze is to decrease this max raw value, and that means what should be the value that are shown in as a full line here. And if that is changed, then it seems like it works in Windows. I'm running Linux, so of course there's no problem. It's designed in Linux. And I'll probably find that area at some point in time, but right now this is a way to avoid it.